Welcome to EMworks webinar series. Our agenda is as follows. A brief discussion about our products and services, followed by the main technical presentation. Then comes the questions and answers period. At that point, a senior application engineer will go on stage and answer your questions. You may then type your questions in the chat section. All of our products are integrated into SolidWorks. Some of our products are equally integrated in Autodesk Inventor. There are a couple of reasons, including, we want to concentrate our effort on what we know best. Electromagnetic simulation. We don't want to reinvent the wheel. In other words, why should we develop a CAD while there are excellent professional CADs out there? Developing a CAD requires much more human and financial resources than a simulation software like ours. Indeed, all simulation companies that made the mistake of developing their own CAD ended up with a primitive and even mediocre software. Why bother about learning a new primitive CAD? Just use your professional CAD and start simulating right away. You can easily collaborate with other departments in your company since all of you use the same CAD model. Some companies that have their primitive CAD claim that you can import files from popular CADs such as SolidWorks or Inventor. It is true, you can import. However, oftentimes you would need to heal, stitch, or clean the geometry because of compatibility issues. Furthermore, if and when you need to make the smallest modification, you must start all over again. We hope that you understand now why we stayed away from developing our own CAD and, instead, relied on the professional CADs. We believe that we convinced you. You may ask now, what are the other companies providing an electromagnetic software package that are fully integrated in a professional CAD such as SolidWorks or Inventor? Look no further. EMworks is the first and the only company that provides electromagnetic software as add-in to SolidWorks and Inventor. As a matter of fact, the integration in SolidWorks dates back to 2007 and in Inventor to 2012. Consequently, we have more products integrated in SolidWorks, which are all gold certified. Our products and services are as follows. EMS is a 3D electric and magnetic field modeling software for frequency ranging from DC to few hundred megahertz. It covers many applications like insulators, cables, bus bars, permanent magnets, actuators, circuit breakers, transformers, and motors. EMworks is an electromagnetic simulation software for RF, microwave, high frequency, and high-speed electrical and electronic devices. It covers many applications including a wide range of antennas, resonators, filters, connectors, and waveguides. EMworks 2D is a 2D and axisymmetric electric and magnetic field modeling software for frequency ranging from DC to few hundred megahertz. It covers the same applications as EMS. Motor Wizard is a template-based motor design software. It offers analytical and finite element analysis for BLDC and permanent magnet motors. In addition to these solvers, we offer several multi-physics modules including motion, stress analysis, thermal analysis, electric circuits, and ECAD. Let's move now to the featured technical presentation.
Welcome again to EMworks webinar series. Why Resonant Wireless Power Transfer is a highly efficient charging technology. Let us first give a quick overview of today's presentations. Type of wireless power transfer systems and applications. Sample of wireless power transfer problem solved using EMworks. Limitations of the wireless power transfer. Definition of resonant wireless power transfer. Difference between a wireless power transfer and a resonant wireless power transfer. Design challenges of an resonant wireless power transfer system and the EMworks solution. Valuable resonant wireless power transfer simulation results obtained by EMworks. Software demonstration. Type of wireless power transfer systems and applications. Near-field transfer based on inductive coupling, capacitive coupling, and resonant inductive coupling. Operates at distances shorter than a wavelength. Far-field transfer based on RF and microwaves coupling. Operates at distances longer than the wavelength. Laser power transmission. As for the applications, portable electronic devices such as smartphones and tablets, electric and hybrid vehicles, implantable medical devices. Samples of wireless power transfer problems solved using EMworks. EMworks can solve any wireless power transfer system, including smartphones, cars, and electric vehicles chargers. However, wireless power transfer has limitations including efficiency is inversely proportional to the distance between coils, 1/distance cubic. Requires perfect alignment between the coils. High power is required to achieve adequate efficiency. Hence the need for resonant wireless power transfer, which has the following characteristics. Introduced by MIT researchers in 2008. Has compensation capacitors in both the transmitter and receiver and operating at their resonant frequency. The compensating capacitors make a big difference compared to a wireless power transfer. They nullify the imaginary parts of the impedance seen by the source, enabling the resonant wireless power transfer to achieve a higher output power and efficiency compared to the wireless power transfer. As you can see in this figure, the resonant wireless power transfer has an additional resonant circuit that includes capacitors. The magnetic flux path is longer for a resonant wireless power transfer. Nonetheless, a resonant wireless power transfer has design challenges, including coil design, distance, alignment, and their effects on the efficiency. Self and mutual AC resistance and inductance calculations. Coupling coefficient. Accurate resonant frequency calculation. Skin and proximity effects. Multiphysics. Thermal and structural. EMworks provides accurate and fast solution to all aspects of resonant wireless power transfer design issues, thanks to its capabilities and features including multi-configuration and parameterization, built-in circuit simulator, AC resistance and inductance, coupling coefficient and induced voltage calculation, AC and transient magnetic analysis, losses calculation, built-in thermal and structural solvers, self and mutual resistance and inductance, magnetic flux density plot. Using the built-in circuit simulator and using the formula for the efficiency. The efficiency for a wireless power transfer stagnates at 0.17%, while the efficiency for a resonant wireless power transfer reaches 11% at the resonant frequency. The maximum of the input and output power takes place at the resonant frequency. The efficiency has a maximum value of around 19% in the range of 2 to 7 mm of distance. It drops as the distance between the coils becomes larger. Nonetheless, it is still more efficient than the wireless power transfer system. The efficiency rises until reaching a maximum of 11% at a load of 10 ohm, then decreases. The load must be carefully selected. Flux density distribution around the transmitter and receiver coils at 2 mm and 40 mm separating distance. Mutual inductance, coupling coefficient, and induced voltage are inversely proportional to the separating distance, as expected. Animation of the flux density versus coils alignment. Mutual inductance, coupling coefficient, and induced voltage are inversely proportional to the alignment distance, as expected. Let us go for a live demonstration next. Since EMS is an add-in to SolidWorks, the creation and modification of the geometry is as easy as a pie. We skip the geometry part and dive straight into EMS. To add a new EMS study, right-click on the project name and choose AC Magnetic. Under the General Properties tab, check Parametrization and compute circuit parameters. Enter 13.6 MHz for the frequency. Under the Coupling Analysis tab, check Coupling to Circuit. No need to check the other tabs, and the default is adequate for this study. Click OK. Applying materials and coils in EMS is very easy. Please refer to other videos in our YouTube channel to learn how. Instead, let us examine the results of some existing studies that were run earlier. The first is a wireless power transfer study with a parametrization of alignment distance between the coils. Under Parameterization, double-click on the design scenarios. We see a total of 7 scenarios corresponding to different alignment distances between the coils. Check OK. Double-click on Results table to examine lump circuit quantities, induced voltage, resistance, inductance, flux linkage, impedance, current, losses and more. Plot the mutual inductance versus scenarios, as shown. Plot the coupling coefficient versus scenarios, as shown. As expected, the mutual inductance and coupling coefficient decrease as the alignment distance between the coils increases. All other table quantities are equally plottable as a function of scenarios. To close the results table, click Close. The magnetic flux density and magnetic field folders contain the near flux density and magnetic fields in the entire model. From the magnetic flux density folder, we can create different types of plots: fringe, vector, streamline and 2D plot. Right-click on the magnetic flux density folder and choose 3D fringe plot, no clipping. The magnitude of the magnetic flux density is color-coded, where the red color is the maximum and the blue color is the minimum, as shown on the legend on the right side of the plot. Click OK. Right-click on the plot icon and animate versus scenarios. Click OK. Right-click on the magnetic flux density folder and add Choose 3D vector plot no clipping. Click OK. Right-click on the vector plot icon and animate, as shown. All the plot performed on the flux density can equally be applied on the magnetic field, applied current density, force density, electric field, and loss density. Let us examine the second study, wireless power transfer with distance parametrization. Double-click on the results table. Plot the mutual inductance versus scenarios, as shown. Plot the coupling coefficient versus scenarios, as shown. As expected, the mutual inductance and coupling coefficient decrease as the distance between the coils increases. All other table quantities are equally plottable as a function of scenarios. To close the results table, click Close. Right-click on the magnetic flux plot icon and animate versus scenarios. Click OK. The last study that we want to examine is a resonant wireless power transfer. To visualize the resonant circuit, double-click on the schematic. The transmitter and receiver have a capacitor of 77.26 and 114.42 picofarads respectively. All results table and field results are equally available for the resonant wireless power transfer study, and the only real distinction is the coupling to circuits and the addition of the resonant capacitors. To answer the question why resonant wireless power transfer is a highly efficient charging technology, as briefly explained in this webinar, the addition of the capacitor and the choice of an operating frequency equals the resonant frequency of the circuits. The transferred power from the transmitting coil to the receiving coil is maximized. It is also less sensitive to the distance and alignment between the coils. No wonder why the resonant wireless power transfer is becoming the #1 power transferring technology for most emerging wireless charging devices. To conclude, whether you design a resonant wireless power transfer or the classical wireless power transfer, EMworks provides you with powerful, accurate, and easy-to-use design tools that help your wireless products reach the market before your competitor. Thank you for attending this webinar and hope to see you in future webinars.
Thank you everyone for bearing with us. And I hope that you have learned from the feature technical presentation. Let me briefly touch upon support offered by EMworks. Our support service is second to none. We always have your back before and after sales. We offer one-to-one web demo sessions to give you a head start and shorten your learning curve. You may even run a benchmark for you if you want to skip the trial option. We offer consulting and design engineering services. We may even propose to you a new design as per your requirement or refine and optimize your existing design. Featured customers. These are just few of our respective clients. These big names, that come from various industries, are true testimonial for the quality of our products and services. I encourage every one of you to try our software and experience its power and ease of use. We offer 2 weeks of free trial license. You may opt for a benchmark instead of a trial license. Please visit our webpage at www.emworks.com. Go to our Contact Us page. Fill in your information and submit your request. We will contact you promptly. On behalf of EMworks, I would like to thank all of you for attending this webinar. Feel free to contact us after this webinar to get more information on our products. Now we pass to the questions and answers period. Please type your question in the chat section on the right of the screen.